All right. So let's talk about this regression as a center line instead of a center point. So here are some reasons for summarizing with a regression line. And notice that for all of these, I'm talking about scatter plots. So regression lines are really used for scatter plots. Here, what we want to do is we want to have some variable here. So here's my first variable, variable 1. And here's my second variable, variable 2. And we'd like to get a line that sort of describes the center of all of these points, all these cases, whatever the cases may be. Why would we want a line, right? Why not just a mean, right? Well, sometimes there's not enough info from just a point. If you just had a point, for instance, let's say this point is the mean of my x's and the mean of my y's, right? So that would be x bar, that's the mean of x's, and y bar, right? So let's say that's my center point. That point might not give us enough information about this whole distribution, right? Remember, we talked about how to summarize a distribution, and we want that trend. We don't just want a point. We would like a trend. And when there's not enough information from a point, it's useful to have a center line. Also, we want to find a summary that describes the relationship between the two variables. So it's not just enough to have a point. The point won't describe the relationship between the two, but a line does. A line will tell you whether it's pointing, whether its slope is negative or positive. The line will tell you that kind of information that you would want from something like a trend. And so that relationship is actually really important to us, and we wouldn't get that information from just a point. The third reason that you would want to summarize with a regression line is that it's often helpful to use one variable to predict the other variable, right? And often, by convention, we would put whatever we feel is the predictor variable on the x-axis. So we may use this to predict this. So we may use someone's weight to predict their height, right? Or vice versa, right? In case of weight and height, it doesn't really matter which is the predictor. And really, predictor variables are by convention. They're not causal variables. They are just variables that we use in order to predict a second variable. And that second variable is called the response variable. And so one thing that's important to know is that the predictor variable, by convention, by just tradition, goes on the x-axis. And the response variable is often portrayed on the y-axis. And so that sort of goes along with this idea of functions, right? That we put in x, and f of x, the function, will crunch out for us an output, right? And that's how we think of predictors. You put in the predictor, and it'll crunch out for you the response, right? A predicted response. Now, when we talk about predictions, those predictions lie on the regression line. So this regression line equals all of our predictions, right? And so this means that, oh, when we think x is, you know, let's say 27, then the prediction line shows us that y would be 180 or something like that, right? And so that all the predictions lie on the actual line. Now, notice that a lot of our points do not lie on the prediction line. And so there's a little bit of difference between the actual data and the predicted data.